Okay, we reach a mountaintop of sorts now. Lesson 28, first of all, it's going to be the last lesson for this particular term, spring 2020. But it combines some nice, hefty algebra kinds of things. It combines factoring of polynomials. That's what this rational expressions is going to involve. You can see polynomial type stuff right there. Combines it with fractions actually, with common denominators and stuff like that. So anyway, it's only 8 examples, but it's a very nice 8 examples to end with, I think. So the first thing I want to do is I want to show you you may not have seen this before. This is a nice approach to finding common denominators, and it's mostly useful when you have fractions that have like weird number denominators like this one, like a 35 and a 49. That's a bummer, right? And it goes like this. Now looking at sixths and tenths, now you might be able to see what the denominator is, but pretend you don't. If you don't, then what you do is this is that prime factorization thing again. You break up the 6. 6 is really a 2 times 3, and that's it, right? Those are primes. You break up the 10. That's really a 2 times 5, and that's it, because those are primes too. So I've done a nice little prime factorization, and so what I've got, instead of 1/6, I'm going to write it as 1 over 2 times 3. Then I'm going to leave a lot of space, and then this 1/10, instead of 10, I'm going to write it as a 2 times 5. Okay. So you factor it up, and then here's what makes it nice, is the next step. The idea is if you want to have common denominators, if you want to have matching pairs, so to speak, matching sets, I should say that. You want whatever's down here to be the same as whatever's over here. Then what we got to do is we got to see what's missing and build it up. In other words, this one's got a 2, this one's got a 2. They both have 2s, that's fine. But notice this one has a 3 and this one doesn't. So that tells us we should multiply top and bottom by 3. Meanwhile, now take a look over here. This one's got the 2, it's got a 3, it's also got a 5, and this one doesn't. So I'm going to have to multiply that one. That looks terrible. I'm going to have to multiply that one by 5 over 5. And now, look what we got here. We got a 2, 3, 5. We got a 2, 3, 5. We have matching sets. We have a common denominator, in other words. So that's kind of cool. I like this method. It works great for big numbers especially. So what we got then is we got over here 1 times 5 is just 5 plus, and over here 1 times 3 is just 3. This is all over the same denominator, right? Hey, this is all over the same denominator. So I might as well put it together now and say, what is 2 times 3 is 6, 6 times 5. It's like, oh, that's a 30 on the bottom. Notice, of course, you get the same thing over here because they're matching sets. 2 times 5 is 10. 10 times 3 is 30. Yeah, you get the same thing either way. So it's 5 plus 3 over the common denominator of 30. So that's 8 over 30. And yeah, we should still reduce, right? You can cancel 2's if nothing else. Call this a 4/15. But the main thing that I was wanting to sell was right here. The old factor it up, factor the denominators, and then make matching sets. That is the key idea. I mean, we're familiar with this idea that, if you want to find a common denominator, you have to multiply by the same thing, top and bottom, right? So that part's not different. The different part is factor your denominators, make matching sets, then you've got your denominator. It's really cool. Watch how it works on this one over here. You got a 35, you got a 49. Do you really feel like trying to find a common denominator in your head? It's like, I suppose you could multiply 35 times 49 if you wanted to, but that's going to be like too huge. It's certainly not going to be the least common denominator. So let's follow what we were doing over here. Step 1 was to factor the denominators. So the 35 is really just a 5 times 7. Those are primes. That's it. 49 is a 7 times 7. Those are primes. That's it. We're done. So the first fraction is a 3 on top of a 5 times 7. And then leave yourself some space. And the second fraction is 2 over you could write 7 times 7, or you could write 7 squared. Doesn't particularly matter. And then you say, okay, So now you take a look at this versus this, and you say, okay, I need these to be the same. I need matching pairs. Notice right away, this one's got a 5, this one doesn't. So to make matching pairs, we are going to have to multiply this by a 5 over 5. I at least know that much. Now you have to keep looking at it until you're convinced that everything's the same. So I've got a 5, I got a 7. I got a 5, I got 2 7s here. I got 2 7s. I got a pair of 7s. So we're not quite done. We're not quite done. If this one's got a pair of 7s, this one should have a pair of 7s as well. Okay? I mean, you can't give a pair of 7s to one twin and only one 7 to the other twin. The twins will get mad at each other, right? But anyway, the point is, we now have matching sets. 5 times a pair of 7s. Matching sets. That means the denominators are the same. That means we're ready to go across the top. Here I got 3 times 7, call it a 21, plus. Here I got 2 times 5, call it a 10. These are all over the same denominator now. So I can put this together. I can say, well, 5 times 7 is 35, and then 35 times 7 is what? So you do have to figure that part out. 35 times 7 is what? I'm going to try to say 245. You should get the same thing here. 7 squared is 49. 49 times 5 would be 245. Yep. So that works. Now we can just go ahead and add the 21 and the 10. Oh, wait a second. That's a subtraction. My bad. Whoa, hey, ho, ho, hey. Let's do it right here. That's a minus. That's a minus. Okay, there. So 21 minus 10 is 11, actually, over 245. And that should say... Look at me go here. That should say equals. There, I think we're done with that one. So you might like this. So if you have big numbers someday, maybe you're stranded on a desert island, you don't have a calculator, you need to do some math. Well, now you've got a nice approach that'll help you with big numbers. Now let's get to some X action. So part B, we got some what we call rational expressions here. Expressions because they involve X, rational because they're ratios or fractions. That's where we use these words. So, well, there's really not a lot to factor here. You're not going to break up the 5. I guess you could break up the 10 as a 2 times 5. So let's just write that, actually. So we got a 7 over a 5 and an x squared, and I'm going to leave a lot of space. And over here I got a 3 over a 2 times a 5 times an x. Cool. That's really all the factoring to do. Now it's about the like, or not the like terms, but the matching sets. I need to make sure that this and this look the same. Right now they really don't. For one thing, this is going to need a 2. There. Now I've got a 2, a 5, and an x squared. I've got a 2, a 5, and it's just an x. I need that to be an x squared, so I'm going to have to multiply by another x. Okay, so that's kind of how you play the game to get the matching sets. So now I do indeed have matching sets. Both of these sets have a 2, a 5, and a pair of x's. A 2, a 5, and a pair of x's. Which means we're ready to add across the top now. So you go 7 times 2 is 14, plus 3 times x is 3x. All over, and then you put this stuff back together. 5x squared times 2 is, well, 10x squared. And if you want to be really careful, you can do it over here too. 2 times 5 is 10x times x is 10x squared. Yep, it's working. Make sure you have perfectly matching sets. So that's really the answer, right? Because these are not like terms. I can't combine them or anything. So what we might do is, just for the sake of standard form, usually we put the x's and then we put the constants like this, 3x plus 14. You might want to just circle it like that. Okay, cool. We're moving now, eh, folks? Now, look at that thing. Okay, it looks a little intense, but really it's just a bunch of pieces, right? So that's the thing about math. You're always playing with a bunch of pieces. Now there's no factoring to do here. It's just x and a bubble, x plus 1, right? That's it. I'm going to leave a lot of space though. Now over here, I've got an x cubed And I've got an x plus 1. Actually, I got a pair of those. That's why it says squared. Okay, time to make matching sets. Here I have an x. Here I have xxx, really. So I'm going to have to multiply by a pair of x's here to make sure I've got 3 in each set. So now I've got x times x squared is x cubed. Okay, so now I have matching sets in terms of the x part of it. Okay, that's cool. Then you have to take a look at this bubble part, the x plus 1 part. Over here it's squared, which means I need another one of these, which means I'm actually going to have to multiply this also by an x plus 1 over an x plus 1. Sometimes you got to multiply by more than one thing, that's for sure. Okay, do I have matching sets now? I believe I do. I have an x and an x squared, which makes an x cubed. That matches. I have an x plus 1 times itself, which is the same as x plus 1 squared. That matches. We're good. Matching sets. Now, we can come across the top here. So this big bunch of stuff, 1 times that is that, x squared times an x plus 1, okay? And don't forget we're adding a 1 here, right? You add across the top. And then you can put your big old denominator on the bottom. It's got an x cubed, it's got an x plus 1 squared, right? That's what this looks like. You can put this together and get the same thing. That's your common denominator. So we should really kind of do some stuff up here. X squared times x is x cubed, and then we'd have x squared times 1 is x squared, and then we would add this 1 along. Okay, that's the top. And, well, I'll just put the bottom back on. Just copy it, really. And that's it. Can't do anything else with that, right? Remember, you're not allowed to cancel things. Like I can't be canceling these, right? Because you've got 1, 2, 3, 4 parts to this fraction. If you cannot cancel x cubed in all 4 parts, then you don't cancel x cubed anywhere. Get the yellow to go away. Okay, there's no canceling to be done on that one. Okay, so hopefully you're kind of getting used to this idea of, you break things up into little factors, or maybe it's already broken up mostly into little factors for you, like in this one. You break it up into little factors, and then the key is to make matching sets. Sometimes you just have to multiply one of the fractions by a bunch of goop, top and bottom. Sometimes you have to multiply both fractions by a little bit of goop, again, top and bottom. But you get the matching sets, and then you'll be able to add across the tops. Just carry the denominator along. Let's get rid of some yellow here. Yeah, good enough. Okay, so notice we're ramping up in difficulty a little bit at a time here. What's going on here? Well, these are similar examples to what we were just looking at. It's just that looks like we've got some factoring to do. These are all things that can be factored, right? You can break this up because it's a difference of squares. This is a trinomial, so we're going to try to unfoil that. This is a difference of squares. This is not a difference of squares, but we can at least pull out an x, right? So there's things we can do here. So let's take... actually, this is 2 separate problems. What do you say we do one at a time? So looking at this problem on the left, the x squared minus 9 is a difference of squares. Recognize it's an x squared minus a 3 squared. So it'll factor as 1 over x minus 3, x plus 3. So that's that one. Now leave some space. Then break up the other one. Well, let's see now. If that's x squared, it has to break up as x times x. The 9 could be 1 times 9, or you know what, 3 times 3 will work because it'll give me the 6 here. So you're going to have an x minus 3 times itself, basically. If you FOIL that, it works just great. Cool. We factored. Now compare. I have an x minus 3. I have an x minus 3. Cool. I have an x plus 3. I don't. Ooh, you're going to need one of those. You're going to need one of those, buddy. Okay, now they both have... let's get a color going here. Maybe this color. Oops, yeah, not that color, this color. I got an x minus 3, I got an x minus 3. I got an x plus 3, I got an x plus 3. You know, this isn't a bad idea. Get yourself a little highlighter going, because as soon as you do that, right, I highlighted the two x minus 3's, I highlighted the x plus 3's, and then all of a sudden I was made startlingly aware that, hey, I haven't highlighted that yet. That's because this guy's going to need one of those, right? The fraction on the right had 2 of them in the denominator. This one only had 1 of them. It needs 2 of them. So you have to multiply top and bottom by this. And then you can finish up and say, yeah, now I have matching sets. Cool. Matching sets, that's the whole deal. Get matching sets. Now on top here, I've got 1 times this is, well, just that. And then I got this plus, don't forget the plus. And then I got 1 times this x plus 3, which is just that, all over my LCD. Now if you don't mind, I'll save that for later. I want to simplify up top here. Notice how this is basically just an x minus a 3, and then if you're distributing a 1, it's not going to do much really. You'll have an x minus 3 plus an x plus a 3 all over the denominator. And so that's going to be x, looking at this, x plus x is a 2x, and then the minus 3 plus 3 are canceling each other actually, so it's just 2x on top, and sooner or later you're going to have to write the denominator down. I have an x minus 3, actually I got a pair of those, which I can just put a square there to show that. And then I have an x plus 3, just one of those. That's a fun game. Let's look at this one over here. Unless you want to try it yourself, this would be a good place to pause and try it yourself, wouldn't it? Factoring the x squared minus 1, it's a difference of 2 squares. It's an x squared minus a 1 squared. So you go x minus 1, x plus 1. That's the first fraction. Leave space because you're usually going to need it. 2 on top. And again, we can pull out an x from here, leaving an x minus 1. Okay, cool. Let's get a new color going. No, not red. Let's get a new color going. Okay. Now, compare your two denominators. So far, actually, let's do this. So far, this is in common. They both have x minus 1. This one, however, does not have the x. Okay, so if I multiply by x, now they both have an x. Notice this one does not have the x plus 1. So you always have to do the same top and bottom. But now they both have an x plus 1. So now I have matching sets. Oh boy, they should give me whiteboards like this in school. This would be fun. Anywho, now we can go across the top. So 3 times x is, well, 3x plus. And then notice we've got some distributing to do. I'm going to actually save that over the LCD, which I don't feel like writing down just yet. So it's 3x plus, and then when you distribute, you'll get a 2x plus a 2 over the LCD. And so our final answer is 3x plus 2x is 5x plus the 2. And at the end, you're going to have to write down the denominator. So make sure you get all the pieces. We have an x. I got that down. We got an x minus 1. Okay, I got that down. We got an x plus 1. Okay, I got that down. That's it. That's all there is to do with that one. Nothing cancels, nothing else. Now we get to the main event. This was the title of the lesson, in fact. Wasn't that the title of the lesson? Something to do with like subtracting rational expressions or something? This is important. Put a big giant hey here. This is important. It's so important that every single one of your homework problems is going to be a subtraction, in fact. Something happens with subtraction that I want you to be alert to because it's one of the most common mistakes I see when people get to college algebra. I don't want you to make this mistake when you get to college algebra. I tend not to give much partial credit when you make this mistake in college algebra because I'll warn you about it there too. But anyway, what am I talking about? Well, let's start this thing. We start this in the usual way. We say, okay, I'm going to have to factor that up. I guess I don't have to factor 3x minus 4. What are you supposed to do? There's nothing you can do, right? So anyway, I do have to factor that first trinomial anyway. So start by factoring it up. Let's see now here. 3x squared is going to have to break up as 3x times x, right? Then you have to play with the 8. Is it 1 times 8? Is it 2 times 4? Is it 4 times 2? Is it 8 times 1? It's got to be one of those. And you just kind of monkey around for a while until you get it to work. Remember, you have to get the inner and outer products to give you a plus 2x in the middle. And let's see if I can do this. How about if I put a 2 here? How about if I get a pencil? How about if I put a 2 here and a 4 here? I'm pretty sure I'm going to get that to work. Why am I pretty sure? Because notice I'll have a 4x in the middle, my inner product. My outer product is going to be a 6x, and I'm thinking I can combine a 6x and a 4x to get a 2x. What I would have to do is have, let's see, that's a positive 2, right? So I would need a positive 2x and a negative 4x, which means make that a minus, make that a plus. And then you just kind of have to double check too. Not only did your inner and outer products work, but make sure that this is still okay. Negative 4 times positive 2 is negative 8. Yep, that's still okay. So that's good stuff. It's all good stuff right now. Good. So that's how that one breaks up. So cool. Let me maybe just write it out as a nice little fraction here. 3x minus 4x plus 2. Leave the space in case you have to do something. Over here, I'm going to write the 3x minus 4 in parentheses so it looks exactly like this one does. So notice I have this, I have this. That part's the same already. What I don't have is I don't have an x plus 2 on this one. So I have to do the old x plus 2, x plus 2. Now you'll notice that I'm supposed to be subtracting. That was the whole thing. I'm supposed to be subtracting. Okay, so we've got the matching sets now because now we both have an x plus 2. The denominators are the same. All right, here comes the danger part. 1 minus 2 times the x plus 2. Okay, all over my common denominator, and I guess I might as well write it. It's not that hard. It's not that big and ugly. So the part you have to hay about is right here. This is a negative 2 that's distributing. I'm going to say here, because what you've got on top is a 1. You've got a minus 2x, and a minus 2 times a plus 2 is a minus 4, right? A lot of people mess up these distributing of the negative here. They just miss it. Be careful not to miss that. I could put this as a negative 2x. The 1 minus 4 is a negative 3, and now I will copy my denominator down there like this. Okay. So again, right there, watch out for that. We had a negative, and that negative ends up distributing and affecting the 2 and everything. It affects this x, it affects this 2. The negative, it has a big, large effect on this problem. So you have to make sure that you don't minimize the effect of your negative by accident. Let's we got the one more problem. Well, you might want to stop and try it yourself, but I'll just kind of groove along here. First thing we want to do, we need to factor these puppies. They're both trinomials, so it's the old guess and check trinomials. So 2x squared has to be 2x times x. What else could it be? Has to be. The 2 has to be either a 1 times 2 this way or 2 times 1 this way. It's got to be one of those two. And I'm thinking this is going to work. You get pretty good at this after you do about 8 million of them. So does this work? I should make sure now. Plus 1x minus 4x makes a minus 3x. Yep, it works. And then I should also check. Plus 1 times minus 2 is minus 2. Yep, that works too. Good, it worked. Yay. Over here, again with the 2x squared. So that has to be a 2x times x. What else could it be? The 3 has to be either 1 times 3 or 3 times 1. See, a lot of these trinomials, they're really not that bad. It's like sometimes there's not that much guessing that's involved. Like here, I've got 2 things to try, right? Now I'm trying to get a 5 in the middle, so I'm guessing I'm going to need this, because that way, notice I get the nice big 6x to work with to combine with a 1x. Trying to make a negative 5x means I should go negative 6x plus 1x, which means that's minus, which means that's plus. Okay, let's double check now. Plus 1x minus 6x gives me the minus 5x. That part works just fine. Plus 1 times minus 3 gives me minus 3. That part works just fine. So we've got it. So now I can start erasing and stuff. So having passed the factoring phase, make sure there's an x there. Look at that. So I've got an x. I have a 2x plus 1. I have an x minus 2. That's the left fraction. Leave some space. Make sure you put minus this time. 1 over. And this one factored as 2x plus 1 times x minus 3. Now, unless you're very unlucky, you should expect at least one of these things to match up. Yeah, see, the 2x plus 1s are matching up at least. But I have an x minus 2 over here. I'm going to need an x minus 2 over here. Okay, now I can say that those match. Notice I have an x minus 3 on the right, which means I'm going to need an x minus 3 on the left. Okay, and now that's a matching pair. Okay, cool. So now I can go across the top. Across the top, take this big thing, x times an x minus 3, minus. Now take this big thing, which isn't much, it's just 1 times x minus 2, which is 1 times anything is itself, right? And then I guess I'll write this down just to be good. Okay. And then once more we enter the danger zone right here. This. When you're subtracting, this is what you got to watch out for. This distributing effect here. It's important. Okay, don't miss that, please. So if I simplify across the top, first I can do this. X times x is x squared, then I have a minus 3x. Now I'm over here in the danger zone, and I'm doing a negative x, and then I'm doing, well, let's do this. Then I'm doing a negative, then I'm doing a negative times a negative 2 to get me a plus 2, okay? So what'd you do? Okay, so I'm going to say over here, especially this, because this is usually where the error ends up. It's like it's amazing how many times I'll see a minus here instead of a plus, but it's a plus, right? The math doesn't lie. This is a minus times a minus over here. Minus times a minus gives you a plus, okay? Meanwhile, we have our denominator, which is the same as that, right? So across the top, let's simplify. I've got an x squared. I've got these two like terms that I can put together. Minus 3x minus x is a minus 4x. Then I get this plus 2 over there. Okay, now let's put the denominator back on there. The common denominator was this. Try to make it look like a single fraction. There we go. You can try to reduce it, but that would involve trying to unfoil that, and I can tell right away it's not going to unfoil because two numbers that multiply to 2 and add to 4, you can't do it, right? 1 times 2 is 3. That's as high as you can get. So you're not really going to be able to unfoil that one. So that's it. That's your answer. That's all you can do. So this is starting to look like real algebra to me, man. Look at all those x's. You got like a half page of x's here. But stay focused on what the little steps are, making common, factoring is a big thing. Building up matching pairs so that your denominators match, that's a big thing. And then the biggest thing in the world, make sure that you're good about this subtraction. So I had x times x minus 3 minus bubble x minus 2, and I already highlighted the big this where it's important to, well, just be careful with your negative. All right, so you can grab the homework. It's down there and below. You might have to hit the show more to see it, but we's done.